All right, so yesterday we worked on exploring absolute value equations, and we went ahead and said that the absolute value of -3 is +3, absolute value of -1 is 1, absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 3 is 3, and the absolute value of 5 is 5. We then took these x values and these y values and put them into coordinate points. We then graphed them on the grid, and we found our parent function for absolute value. I then wanted you to look at these equations down below. How is this different from the parent function right here? Well, these ones have subtracting a number on the outside of the absolute values, and 5 through 8, we are adding a number on the outside of the absolute value. When we graphed this one, we saw that on the graph, the parent function starts at the origin, okay? But when we put in x, the absolute value of x minus 3, we saw that our graph actually shifted down 3 points, and the v started down there. Then we did note that the slope stayed the same, so we're always going to make our v by going up 1 over 1, up 1 over 1, and same on the other side, up 1 over 1, up 1 over 1. So we did the same thing with these v's, up 1 over 1, up 1 over 1, on both sides of the v. And then we went ahead, connected our dots, and made sure to draw arrows on the end so that we know it goes on forever. When we did the absolute value of x minus 5, we started at the origin and we went down 1, 2, 3, 4, 5. Then we went up 1 over 1, up 1 over 1 on both sides so that we could draw a straight line to connect our v. We did the same thing with the absolute value of x minus 1. We started at the origin, we went down 1. Then we went up 1 over 1, up 1 over 1, up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1. And the last one, absolute value of x minus 9. So if I start at the origin, I now have to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to do the same thing with my v. I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, connect my dots. And then up 1 over 1, up 1 over 1, up 1 over 1, and connect my dots. Hopefully you guys are using a straight edge when you do this so that your lines look nice and pretty. I can only hold the phone with one hand and write with the other hand, and unfortunately I don't have 3 hands, so I can't use a straight edge. Now, then I asked you guys to look at question 5. How was number 5 different than number 1? Well, this is minus 3, this is plus 3. Minus 3 means us go down 3 from the origin. So what do you think plus 3 is going to do? Most of you were able to figure out yesterday that plus 3 meant that we went up 3 from the origin. So if I start at the origin, I'm going to go 1, 2, 3 and make my first point. Then I'm going to use the same thing for my slopes. Are going to be up 1 over 1, up 1 over 1, up 1 over 1. Same thing on the other side. Up 1 over 1, up 1 over 1, up 1 over 1. And you go ahead and draw the graph. Same thing for 6. If I start at the origin, I should go then up 5. So if I start at the origin, I go up 1, 2, 3, 4, 5. And then I'm going to go up 1 over 1, up 1 over 1, connect my dots. Oops, my paper's moving. And then I go up 1 over 1, up 1 over 1, and connect my dots. I'll let you guys go ahead and graph 7 and 8 if you didn't do so yesterday. Now, not all of my classes got on to question 9. How is 9 through 12 and 13 through 16 different from 1 through 8? Hopefully you've noticed that on 1 through 8, we're adding or subtracting on the outside of the absolute value bars. On 9 through 12 and 13 through 16, we're adding or subtracting on the inside of the absolute value bars. Now, if you were to put this in a graphing calculator, this is what you would see. For number 9, you would see a graph that starts right here on the x-axis and then goes up 1 over 1, 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 up 1 over 1. So our parent function starts right there. But this graph, if we're not starting at the origin, we're shifted over 1, 2, 3 to the left. Now if I were to put this one in the calculator, it would start right here, and we would go up 1 over 1, 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 up 1 over 1. Same thing with x plus 1. It would start 1 to the left, and we would go up 1 over 1, up 1 over 1, up 1 over 1, and up 1 over 1, up 1 over 1, up 1 over 1. And for number 12, we're going to start at where? If I start at the origin, how far to the left am I going to go? Hopefully you said 9 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, up 1 over 1, up 1 over 1, up 1 over 1. Connect the dots. Up 1 over 1. Oh, we're off the grid. It's okay. Just go ahead and draw on your line. And that is what 9 through 12 should look like. So if adding made us go to the left, what do you think subtracting on the inside of the absolute value bars is going to do to the graph? If I were to graph the absolute value of x minus 3, I would start at the origin, and then hopefully you guessed that it's going to go to the right 3. And then we're going to go up 1 over 1, up 1 over 1, up 1 over 1. Connect the dots. Up 1 over 1, up 1 over 1, up 1 over 1. Connect the dots. Now, I want you to graph 14 through 16 on your own. You can pause the video here and then continue once the whole class has gone ahead and graphed 1 through 16 completely. Once you've gone ahead and done those graphs, I would like you to read through these and try to answer these questions using the answers right here. So these are your 4 options for each of these questions. These questions you are going to potentially see tomorrow. Now what happens if we have something on the inside and the outside? So for this one, I have a plus 3 and a minus 2. Now remember, on the outside it means that we're going to go up and down. Translating up and down is a vertical shift. On the inside, that means we're going to go left to right. Left to right is a horizontal shift. When I have a negative 2 on the outside, that means I'm going to go down 2. When I have a plus 3 on the inside, that means I'm going to go to the left 3. So I go down 2 and to the left 3, and that is where my V is going to start. My slope is then the same. We're going to go up 1 over 1, up 1 over 1, up 1 over 1, connect the dots. Up 1 over 1, up 1 over 1, up 1 over 1, connect the dots. And there is my absolute value graph. For number 2, we have a negative 2 on the inside and a positive 3 on the outside. I know that the positive 3 on the outside means that I'm going to go up 3. The negative 2 on the inside means that I'm going to go to the right 2. So I'm going to start at the origin, and then I'm going to go up 3 and to the right 2. I could also do it the other way. I can go to the right 2 and then up 3. Either way, it gets me to the same point. So I go up 1 over 1, up 1 over 1, up 1 over 1. And I go the other way, up 1 over 1, up 1 over 1, up 1 over 1. Connect the dots, and there's that V. Number 3, my negative or minus 5 on the inside means that I'm going to go to the right 5. My minus 1 means I'm going to go down 1. So I'm going to start at the origin, and I'm going to go to the right 5, 1, 2, 3, 4, 5, and I'm going to go down 1. And up 1 over 1, up 1 over 1, up 1 over 1. And I'm going to connect the dots. Sorry, it's hard to connect the dots. And that is what that V would look like. I would like you to try these 3 problems on your own. That is your homework. It needs to be done by tomorrow. If you would like to move on and work on these problems, please do. I'd like you to maybe take a guess. You can graph all of the ones that are in blue right now, and you'll have to think really hard about what you think might happen with the ones in red. I hope you guys are behaving and have a wonderful day. I'll see you tomorrow. Bye.